All right, so again, when we have these exponential ones, like number 1, 6, and 7, 4, 6, and 7, no, 4 and 6, sorry, 1, 4, and 6, okay, what we're gonna do, we're just gonna take the log of both sides. Okay, and when I do that, I can move this exponent out front because our properties of logarithms and multiply it by the log of 2. And then the right side is the log of 32. All right, so that's how we get that exponent out of that exponent area. Get it back on normal ground, I guess, like we're used to. Okay? So again, we're going to do this same procedure on 1, 4, and 6. Okay? And then 8b, we'll do this as well. All right, so then what we're going to do is we're going to take this log on the left to the other side by dividing. Because when I put that x plus 1 in front, I'm multiplying it by the log of 2. All right? So I have to divide the log of 2 over to move it. You know, what you do to one side, you have to do the opposite to move the opposite side. So opposite of multiplying is dividing. When I do that in my calculator, that log of 32 divided by log of 2, you get the number 5. So then it makes it a really easy equation. But again, when you hit that log button, remember, you have to close it off. Or it'll give you a different answer if you don't close it off. All right? So there's where the 5 comes from. So it's a real easy equation now. X plus 1 equals 5. So we're just going to subtract 1 for both sides and get 4. Right, Connor?
Yes.
That makes sense to everybody? All right. Questions? Yeah.
For all like decimals, are we just rounding to the hundredths or?
Hundreds, tenths, or hundreds is fine. Don't have to get crazy. All right. So now number 2, it's a log problem. All right. So the log problems. We change to exponential problems. Right. We should be able to write a log as an exponent problem. Right. And if there's no number here, what is it? If there's no number written, it's a 10. That's our common base 10 log. That's the one that you can use in your calculator. All right, so all we're doing is taking this number, 3x minus 2, whatever comes after log, equals this subscript, that's the base, and 2 is the exponent. So that's our problem. We just add 2 and divide by 3. Okay? So that's not a hard equation once you write it like that. Okay? Remember, you guys all know 10 squared is 100. So this becomes 102. And then just divide by the 3. What is that? 90, what? Not 90, I'm sorry. 34. Thanks. What was I thinking, 90 something? Yeah. All right. Those two make sense? All right, now number 3 is a little bit more difficult because I have 2 logs. So what I have to do first is condense that one on these 2 on the left into a single log. Okay. So the difference between 2 and 3, 2 is already a single log. So right away I can write the this exponential equation. So number 3, I have to turn this into a single log first. I got to condense it. And then I'll do what I did in number 2. Actually, I won't have to do what I did in number 2. I'll show you why. All right, so when I have addition, the two numbers to condense, I do what to them? Multiply. If this was subtraction, what would I do with those two? I would divide, okay? So just pay attention if it's addition, it becomes multiplication, or if it's subtraction, you would write it as division instead of multiplication. Okay, so that's the problem now. Now this is much actually easier than number 2, because if I have log base 2 of something equals log base 2 of this, what must be true about this and that? They gotta be the same, right? They gotta be equal. So all I have to do is drop these logs when I have one on each side. Okay? So on the left, I'm gonna go ahead and distribute. And that's my equation right now. Now, since it's x squared, we call it quadratic. We got to set it equal to 0 to solve it. We got to subtract that 4 over. And the first thing I would try to do is to factor it. But when I try to factor that, there's no factors of -4 that'll add up to +6. So I'm going to have to use the quadratic formula, right? So I have to use this. Okay, you guys know that. We've done that a bunch of times. So b is 6. So it's -6 plus or minus. And 6 squared minus 4 times 1. A is 1 and C is -4. All over 2A, which was 1. Okay? So I've got -6 plus or minus over 2. And this becomes 6 squared, 36. -4 times 1 is a -4 times another -4 is a +16. So that's a 52. Didn't come out nice, that's okay. But we should simplify that. You guys know how to simplify 52. Just do a factor tree. And I believe 4 goes into it like 13 times. So what do I do with that 4? What comes outside? 2, right? Square root of 4 is 2. So over here, I've got x equals -6 plus or minus, not 4, sorry, 2, we said we're going to pull out, times the square root of 13, all over 2. So 52 became 2 radical 13 because the square root of 4 was a 2. Now, these are all even numbers, so I can divide all those by 2. So I get -3 plus or minus the square root of 13. Remember, there's 2 answers there. Do both of them work? -3 minus the square root of 13 is still going to be negative, right? If I subtract from a negative, I still get a negative, right? Can I take the log of a negative number? No. So actually, the only answer that works is the addition one. If you actually put that in your calculator, I think I did that. No, I guess I did. But you could if you wanted to. That's fine. Leave it like that. So you probably get one that'll work out like that, where you have to do the quadratic formula or factor it. Okay. wait tomorrow for A and B, maybe it'd be nicer radicals, maybe they'll be perfect squares, I don't remember that. Questions on that one? So again, what we had to do, we had to just turn it into a single log first, okay? And then we had log on each side, so it made it even easier than the other ones. All right, number 4 is another exponential problem that I'm going to take the log of both sides. So I'm going to, right away, I'm just going to say log of 11 to the x equals log of 301. Again, our rule for logs or a property means I can do x times the log of 11. That's the same thing. So all I got to do is divide by log of 11 and I'm done. Because all there is on the left is x. So log 301, close it off, divided by log 11. So 2.4, 2.38, doesn't matter. Just show your work. I see what you're doing, you'll be fine. Questions on that one? Okay. Number 5, we already have a single log, so I don't have to put anything together. Say 7 log. Okay, so I got this single log, the base is 7, so I can say this number, x squared minus 19, or plus 19, sorry, equals the base 7 to the 3rd power. That's my equation. So when I subtract 19, I get x squared equals 324, isn't it? 7 cubed, 343 minus the 19. Yeah, 324. Well, that's a nice number. Why is that a nice number? It's a perfect square, yeah. So, remember, when we solve the quadratic and we take the square root of both sides, you gotta put that plus or minus symbol, right? And the square root of 324 is 18. Okay? So if I use negative 18 and I square it, I get a positive number, don't I? So is negative 18 okay to use in this problem? Yeah, so both of those work. This has 2 answers. Alright, so not all the negatives are wrong answers. Sometimes they still work. Right, Zion? Questions? We all right? Again, this is a pretty easy test or quiz tomorrow. So let's stay focused so that we do well. Some of us are getting down to where we don't want to be. All right, number 6 is another exponential that we're going to take the log of both sides. All right, so remember, when I take the log of both sides, I can move that 5x minus 2 out front of the log. So that's what I've got. Divide the log of 9 over to the other side. And then you just have a pretty easy equation to work with. So log 412 divided by log of 9. 2.7. So then add 2 and divide by 5. I add 2 to 2.7, I get 4.7. Divide by 5. I guess I could do this. Let's clear that. Just do plus 2 right now. And divide it by 5. So 0.95. I round it to hundreds. We okay with that one? Mason, you good? All right, number 7. Very similar to number 5. This time our base is 6 for our log. So the number 4x minus 21 equals the base 6 to the 3rd power. So 5 and 7, 2, 5, and 7 are really easy. All right. Add 21, and you get 4x equals 237. When you do 6 cubed plus 21, divide by 4, you get x is 59.25. So if you put 59.3, that's okay. Any questions on 1 through 7? Simple, right? Okay, this last one, we had stuff, we already did one very similar to this a couple weeks ago. You're given a formula. The temperature after T minutes of the, what is it, soda this time? Yeah. It's this formula, 36 plus 43 E to the negative 0.058 T. All right, so that's the formula we're going to use for this can of soda. It was 79 degrees, it's placed in the fridge, that's 36 degrees. The temperature, capital T, after T minutes is given by that formula. Find the temperature to the nearest degree of the soda 5 minutes after it's placed in the fridge. All right? So all I gotta do is put 5 right here. All right? So just put in your calculator this. And when you put this in, it looks like this in your calculator, e to that caret, and negative 0.058. Remember, times 5. All right? That's all you got to do there. All right, so 36 plus 43. How do I get that e caret to show up? Second ln, right? Second button, then ln. Then you get that e caret to show up. And the negative 0.058 times 5. And then in mine, you got to close it off. Some of you have a newer version, and it puts it up there for you. Just hit the right arrow key so it drops it back down. And then hit enter. So 68 degrees. So it dropped from 79 to 68. Still kind of warm, probably. Now, part B says, when to the nearest minute will the temperature be 38? Well, it'll be nice and cold. All right. Now, we did this one way, without solving last time. You could have put it in your y equals and look at your table. You can still do it that way if you want. But now that we know how to solve logarithms, that's how I'm going to do it. So now we want the temperature, capital T, to be 38. I want to solve for T. So it's an exponential equation that I'm going to solve. Okay? Before I do that, I want to get this e to the power alone. Okay, so I want to move this 36 over and the 43 over. How do I move the 36? Subtract it, right? So I get 2, and then I get 43e to the negative 0.058. How do I move the 43 over? Division, right? That's 43 times e, right? So that decimal, 2 divided by 43, is 0.0465. Now, we had an equation on Monday's homework that said e to the x was 10, I think is what it was. How did I get rid of that e? You guys remember? Did what? Natural log, yeah. When you see that e as a base, you hit natural log in front. Instead of log, we want to do natural log. What happens to those two things? They just cancel out for you. Okay? So that is the answer. When you take the natural log of e to a power, that power is the answer, that exponent. So now all I have is this on the right, because I took the natural log. So I'm going to go natural log, ln, of this answer. So I hit second negative sign for that answer to pop in there. And that's negative 3.068. Now, the last step is to do what? What do I do now to get t along? How do I move this? Divide it, yeah, because it's multiplication, right? It's negative 0.058 times t, so I'm going to divide it. So in my calculator, I'm going to hit divided by negative 0.058. We're going to get 52.8. So to the nearest degree would be what? Minutes, I guess. We're going minutes. 52 to the nearest minute would be 53 minutes. Okay. So 8B was checking to see if you could still solve one like 1, 4, and 6. You just had a little more work because it was E instead of taking the log. And we could have taken the log. We'd still get the same answer, normal log. But when you have that E, you take natural log, it just cancels them out. Whatever that exponent is what's left there. So it makes it pretty easy. Questions? All right, so it's quiz tomorrow. Practice tonight, go through it again, so that I'm giving lots of stickers tomorrow.